I carried out the titration of a strong acid with a strong base by putting 15 milliliters of 0.1 molar hydrochloric acid in the beaker and 30 milliliters of 0.1 molar sodium hydroxide in the burette. I then added a drop of phenolphthalein indicator to show when my equivalence point would occur. I set up a ring stand with a pH probe and a burette and began adding sodium hydroxide in 2 milliliter increments until I approached my equivalence point. I added the sodium hydroxide and then stored how much I put for my graph. After adding the sodium hydroxide, I had to stir the solution to ensure that the pH was constant throughout. The rest of this video is a very repetitive process, so I sped it up and put it on bunny mode.
You tried everything, but you don't give up.
When the pH reached 4, I began adding in 0.5 milliliter increments. When I added 0.5 milliliters of sodium hydroxide to the solution when the pH was at 4, the pH jumped up to 5, so I knew I was approaching my equivalence point.
Well, I'm in the days from your love, you see. I came back to let you know, got a thing for you, and I can't let go. I only want the best, it's true. I can't believe the things I do for you. What you won't do for love. You've tried everything, but you won't give up. In my world, only you made me do for love what I would not do. Made me do for love what I would not do. Make me do for love.
The solution changed colors at a pH of right above 8, so we know that the equivalence point has been surpassed, which occurred at about a pH of 7. I then began adding sodium hydroxide in larger 1 milliliter increments, since the pH was changing at a slower rate again. On our graph, we see that we clearly got the desired curve shape from the titration of a strong acid with a strong base, and we see that our equivalence point is around 7, which we would expect with a strong acid and strong base.